Start recording, that's what I wanted, not start okay. So now the rest of this will be recorded. The rest of it's more important anyway. All right. So going back to here, there's a video on installing. Let's go back to the modules. There's also, and I want to talk a little bit about some of the preliminaries. There's also, although I left off the LF tutorial, there is a Postgres SQL tutorial done by Postgres, and it covers most of the stuff that we're going to cover in their own way. So if you wanted to look at another tutorial besides what videos that I have and the assignments, you can certainly do that. For each of the other things, like simple selects, it has the chapter, it has the assignment, and then it has the chapter, it has the assignment, and then there's a video for each of those. And the same with joins and subqueries and all of that. How many of you have done some SQL? Other than the 220, more than that? So SQL is, just real quickly, I think it's a really pretty simple language to get started with. It's fairly English-like in that it most of the time when it explains, the syntax reads relatively normal English. Not always, but usually. It still can be complex because it is a computer language. The things that'll trip you up the most are commas and semicolons and parentheses, right? And spelling. All of those things can cause problems because it is a programming language. Everything has to be spelled correctly and has to have the right punctuation. It is not case sensitive. SQL is not case sensitive. In some database contexts, the values can be case sensitive. So for instance, if you want it, Seattle might have to have a capital S. I don't think depending on your installation, but generally it's not case sensitive, even for the values. But it can be, you can make it case sensitive. That's nice because a lot of programming errors are usually case related. It doesn't matter here. SQL is considered a fourth generation language. Doesn't matter a lot either, but does anybody know why? So first generation language, just to go through. Anybody? Zeros and ones, machine language, switches on and off. So that's first generation. And people used to write code in zeros and ones. And how they stayed sane, I don't know. You had to be an electrical engineer to some extent for that. The second level is, my brain just went out, assembly. So assembler or assembly is a verbal overlay of zeros and ones, right? Instead of having to write zeros and ones, you can write words, but you're still really close to the machine. So you still have to tell it to go fetch it from a particular memory address, move it to another address, do X, and then what processes you're going to do with it. It could take 30 or 40 commands just to print something, right? So that's what a second generation language is. And they still use that when they're writing probably drivers, hardware drivers, operating systems, things like that. Although most operating systems are written in C these days, at least the Linux ones. And C and Python and all the languages that you've probably worked with are third generation, which means that they're procedural. That means you still have to say step by step what you're going to do. They are not like assembler because you can, instead of saying 30, 40 commands to print something, you can just say print. Each command is essentially a batch file of machine language commands. It'll do a whole bunch of them. Computers don't understand programming languages at all. They only understand the machine language. So that's what compilers and interpreters do. So they turn them into machine language. SQL is different than all of those because you don't have to say what you're going to do step by step. You don't have to say how it is going to happen. You merely say what you want to do. So you just say select star from person. Select is the command. Star is a wildcard for select everything. From is a keyword, and the word that follows it is a table name. Right? So select star from person. You don't have to tell it how to do it. If you were writing that in C++ or C or Python, you'd have to say, go find this file, loop through it until you find all these values, write them into some kind of structure like a list, and then bring them up for display, print them, right? But you don't have to do all of that. For what it's worth, underneath in C or C++, it's all being done that way. But you don't have to do it in SQL. So SQL is a fairly easy language, but as you'll see, there are complexities in it when we get more advanced. All right, so I did a module for each of the different kinds of things. Simple selects. There are two assignments there, basically, which are selects and functions. Let me just open up. Oh, that's the chapter. That's not what I want. And again, if it can't be shown in the frame here, just click that little thing and it'll go to it. But that's not what I wanted. What I wanted was the assignment itself. Select queries. So it has a set of questions. And I'm going to show you the databases that these are based on in just a moment. Run everything from the certificate table. So I didn't say select star from certificate, but that's essentially what that is, right? So you do have to kind of interpret the English into SQL. Usually when I say return, that means select, just to give you that. This one has some specific fields, right? And then it also has an alias. But each of these is a question. If you don't understand the question, please ask me. They aren't all crystal clear. I try, but they aren't always. And if what you turn in is something that is a reasonable interpretation of it, even if it isn't what I meant, I will give it to you probably. Couple of other things. When you turn these in, I'm really mostly just interested in the SQL. I don't need to see the response unless I specifically ask for it, the results. Also, there's a rubric here for each of these. They're not necessarily real things, but these are basic select, sorting, where clause, distinct. So there are different things that are going on there. That's interesting. So there will be a rubric. I will never take it. Why is it doing that? It's weird. Is it going to do it again? Yes. If I leave the student view, will it go away? Is it going to pop down again? All right, never mind. If I will never take a point off without an explanation. If you are missing a point or two and there's no explanation, assume it's a typo. It happens. Tell me about it and I'll fix it. Right? If I take a point off, there will be an explanation why. Also, if I take a point off, you can redo it and get the point back. Right? So you can turn these, you can redo these if you have some problems. Sometimes it might be worthwhile, not sure I want to encourage this, but just turning in a mess that isn't working to get the feedback and then redo it. But also, if you come to class on Tuesdays, you can get feedback. So I am not strict about these dates. That being said, I really prefer you don't pile all up until the end of the quarter. Couple of things. If you do them all at the end of the quarter, you won't have time to redo things if there are things that are wrong. Also, I'm crankier when they all come in at the end of the quarter. So sometimes I'll note something that could have been fixed, but I won't necessarily take a point off. So at the end of the quarter, I might take the point off. Depends. Depends on how the quarter went, I guess. So anyway, these exercises are in the book, but they're also, I repeated them here. I just copied and pasted them. Questions on assignments? The other thing is when you turn these into Canvas, you can take the SQL file and upload it directly to Canvas, or you could paste them into a notepad, or you could just copy and paste them into the text area. You know how there's a text, basically text, they all work. Canvas is smart enough to interpret SQL as text, so because it is just ASCII text. So even if it has the .SQL extension, it usually does just fine with it. And it also works if you paste it into a Google Doc and share that, whatever you want to do. Okay. Any other questions? So there's the modules. There are the assignments. There are videos, and there are chapters. There are a couple of exams. Let's go back to assignments. They're also in the, let's do it in modules. So these are just multiple choices. And you have, I believe, 3 shots at it. There's 4 answers and you get 3 shots. And I think it tells you which answer it is if you get it wrong. So they're not really meant to like create a curve or anything. They are there just to reinforce the concepts, particularly the verbal parts of the concepts, the vocabulary. One of the things that I hate about regular exams is if you get a question wrong, that's probably how you're going to remember it the rest of your life. You remember the wrong answer, not the right answer. So if you have a chance to correct it, it should give you, hopefully you'll remember the right one at the end. These can be done anytime. I wouldn't suggest doing them until you've got the material down a little bit, but they're available. So that's the syllabus. Are you guys okay with that? All right. I want to show you the databases, and I would have you do this. You could do it if you're on your own machine, but if you're going to be using these computers, I would suggest waiting until next week to set this up because we don't have the virtual machines yet, and they should be here by next week. Otherwise, I will have to come around to everybody's machine and give permission for the install, which we may do. If they aren't here next week, I'll do that. In fact, what I'll do next week is I'll just share my password and then change it after. But I don't want to do it this week. Give it a chance to have the other. So I am going to do this, which you may not have. I'm going to bring up PG Admin. And I'm going to get the databases that we're going to be using for the class too. Sometimes this takes a while, and I don't know why, particularly if you haven't done it for a while. Now, it will launch into whatever your default browser is. As I said, does notes. They're taking longer than usual. But it usually launches anyway, though. All right. When you set it up, by the way, I want you to, this is really key if you go home and install this, don't forget your password. It is possible to recover the password, but it's a pain, and it involves a lot of command line work, even on Windows. So the password that I always use is password. There's actually, this is for the server, the base server. And I'm going to do, I'm pretty sure. All right, and then I'm going to open up this. and it asks for the password again, and I used p at ssw0rd1 again here, which you could do. Although another thing that actually could be useful, and I'll show you later, is to create a user with the same name as your login to Windows. This is on Windows or Mac too. And give it the same password as you use to log into your machine. If you do that, then you're logged in, right, when you come in. So it works. Now I have Community Assist on here. I'm going to delete it because I'm going to reinstall it. Delete, drop. Okay, and I'm going to get rid of test. Couple of things. Notice how easy it is to remove a database. That's kind of scary because there's no undo. A lot of things in SQL, and this is true of everything I've ever worked on, there are no undos. You can create real disasters by accident if you aren't careful. And I'll talk about that. Another thing I want to note, I'm not going to do this right now, but particularly on Windows, this isn't a problem on Linux. I don't know about on the Macs. They change this. They do little updates like every 3 or 4 days, I swear. And you can keep up with them if you want. It's not a big deal to reinstall the PG admin. It only takes a minute and it launches again and you're back where you were, or you can ignore them. It's up to you. On Linux and on the updates are done in the background, so you don't have to be aware of them. I have not ever noticed much of a big difference between versions. They add little features, and some of the features are really on the advanced end. I'm going to get a database. Notice we've got one database here. This is Postgres. And generally you don't want to mess with this database. It's a system database. Every relational database management system out there has a system database because you need a database to keep track of databases. And you need a database to keep track of users, and you need a database to keep track of system-wide things. And one of the rules of a relational database is that all information, even information about information, metadata, is stored in tables. It's all queryable, right? But just as a warning, I mean, don't mess with the Postgres database because you might end up having to reinstall Postgres. And that's true of any system databases in general. You should leave alone unless you know exactly what you're doing. So, and you don't want to delete this. If you delete this, you're just dead. You'd have to reinstall. I don't know if it would let you delete it. I'm not going to try right now. But, so I'm going to go to, don't need YouTube. I'm going to go to GitHub. So I'm going to do github.com/spconger. And this is in some of the pages when it talks about getting the database and stuff, or at least there are a couple places where it talks about that. So I'm going to go to GitHub spconger. And I hate Bing, but that's what I'm in, because it always gives me something other than what I'm looking at the top. So, and it's under database schema. So, you guys know GitHub at all? So, you actually, for this class, you never have to go back here again if you don't want to. Although, if you want to post your assignments on GitHub and give me that link, that would also works. But you don't have to use GitHub for this. I'm going to click on database schema, and they're actually under other scripts. All of this is described in the chapter and elsewhere. I'm not sure if this is where they'll remain when the book actually is live. So the ones that we're going to use are Community Assist PG-SQL and Text Certificates SQL. This one has Community Assist PG-SQL because I wanted to make sure that Postgres one was different from the SQL Server one. I might even have a MySQL one version of it. So I'm going to, actually what I want to do is just click it. Click, go. All right, so what it does is it has all of the code to create the database and populate it in SQL. Couple of things I would do raw. Raw gives you the code without the formatting, right, which is what you want. I'm going to just do Control A, Control C. I'm going to go back to PG admin. Now, I did not include the create database in the script, so what I'm going to do is right-click, create database. And if you guys need help with this when we actually do it, this is fine. I'm going to call the database Community Assist. If you want, you can call it Community Assist PG. I'm just going to call it Community Assist. Couple things, don't space. You can underscore if you want, or you can do like I did in capital. It's actually all going to be lowercase in the object window over here anyway. We don't have to do anything else. We don't have to set any parameters. We don't have to do anything like that. If you're curious, what the SQL does is it shows you the SQL for doing this. So a couple of ways to create this. You can copy and paste that, or what I'm going to do is just say save. And it will create a database slowly. It does take it a moment to create it, but yeah.
If on that screen we want to just copy paste everything from that other page, would it work?
I don't think so.
I was just curious.
Yeah, I've never tried that, but I don't think it's a live window.
Oh, okay.
What you want to do now, so we have Community Assist, right? So I'm going to click on Community Assist, and it has a whole structure here. Most of these are not going to be that relevant to us because this isn't actually going to be a course in Postgres. It's going to be a course in SQL. So it has things, we will use catalogs a little bit. That's system tables for the particular database. Schemas is where the tables go. First time I ever went into Postgres, I was lost because I couldn't figure out where the tables are. And there's a public schema, and way down here there are tables. And that's where our tables will go. There's nothing there right now. So if I click on that, it just doesn't do anything because there's nothing there. So up at the Community Assist level again, I'm going to right click and I'm going to get the query tool. And this query tool is where we're going to do most of our work because this is where you write SQL queries. I'm going to drag the, no, I don't want to do that. There we go. I want to drag that down a little. I'm going to paste, and it has all the code that I just did. I will show you how to do this too. Originally I wrote it all out by hand, but this code is actually done by backing up a database. You can back it up as SQL, or you can back it up in a more binary format if you want. So I'm going to hit the lightning bolt, which is way over here. That's the execute. Why can't it? It's not an empty query. Execute. There it goes. All right, so down here it says query returned successfully in 1 second and 52 milliseconds. And if I refresh down here on tables, you'll see that it has all the tables there. And if we look at these tables, we will see data. I'm going to do a new query window just so it's cleaner. So I'm going to go up, query tool, And just to show you, so there's a person table here. A couple of things about this when you're over here is you can click the little arrow and it'll drop that down and it'll show you the columns and it'll show you the constraints. It'll show you the indexes. You know, it has all of these different things. We will make a couple of triggers before the end. So I'm going to just do select star from person, and I'm going to do a semicolon. Semicolons are kind of, it doesn't really require them except in certain circumstances, but you might as well put them everywhere at the end of a statement. Notice it highlights keywords, colors them, which is good. The convention is to do these all caps. I'm too lazy to do that generally, but when I do it in without the color coding, I do them all in caps. If I execute this, it will show me the data that's in the tables. Right? So that's one of the databases. The Community Assist one is the one that's used for examples in the book, and it's used in the videos for the in-class stuff. The assignments are actually based on the other database. So I'm going to go back here. And again, I will help you all do this if you have any problems. And next week we'll get started for sure, whatever the situation is. If you want to start before then, you can put this on any machine. Couple things to know though, if you have it on multiple machines, they won't be in sync, right, unless you put it on the cloud. So I'm going to do text certificates. And I'm going to go over these databases in just a moment. But same thing with text certificates, do raw, copy it. You can also do, well, I was going to say you can do some of the other databases there, and yes and no. Some of them are for SQL Server and other database. They don't necessarily translate directly. All right, so I'm going to go back to PG admin. Again, I'm going to go up to databases, create database. I'll call it text certificate. And basically it's like a school where it's an online school for getting certificates in tech subjects. I made both of these databases. They're not real. I tried to make the data consistent. It's more or less consistent. Tech certificates has a couple of tables that have a couple thousand records. So it's got enough that you can't see the answer right away, which is good. None of them are big enough to really make things like indexes or things meaningful, but I would like someday to have a huge database, but you can't do a script like this if the database is overly huge. Do you know what I mean? I did one time where I had 500,000 records. I tried to do it as SQL. It came out to, if you tried to print it, it was like 950 pages, and it buffered out your computer. You couldn't load it. So it won't work if there's a lot of data. Couple things, it doesn't really matter what you name this. The script will run either way, but so if you don't type it exactly right, it's not a problem. Again, though, don't do a space. Spaces are a problem. All right, and so here's text certificate. I will do a query tool. One of the things you generally want to do a query tool for each database. If you get an error that something doesn't exist, it may be because you're still in Community Assist, right? When I'm opening them at the database level, they're always at they're for that database. I'm going to paste. I'm going to 1 minute and 38 seconds. And then if I look at text certificates under schemas and tables, there's that. Now, you should only have to do this once throughout the quarter, just when you set up, and then you should have the databases from then on. Couple of things about them if you totally screw up, which is not likely, but is a couple of times possible. You can always delete it and reinstall, right? So you're never farther away than GitHub from at least getting back to 0.0. These databases, I mean, they're there. You can always do that. As I said, you're welcome to look at some of the other databases there. I don't know. Not sure what other ones are actually Postgres. One further back. Never mind. I'm just messing there. Database schema. Bakery might work. I don't know though. 2017 SQL. I think these are all SQL. So let's not worry about them. I mean SQL Server. Questions so far? It's not hard to install these, but it'll take a little bit to get set up. If you're going to be working in the lab here, as I said, we may need to spend a little bit of time next Tuesday setting things up. The first assignment is pretty easy too, so if it does take us some time, you still should probably be able to get started on the next assignment, first assignment. First assignment is just selects, which is the kind of stuff you've probably done. I'm going up chapter 1 just to kind of briefly go through it, and then we'll probably call it for today. I'm going to see if I can make this a little bigger. We're not going to read it. That's something you can do. So, the chapter 1 does some things like setting things up. If you need some review about relational databases, it talks about that. It talks about relational design. It talks about Postgres and page admin, and it also goes over the databases that we're using. In the chapters, there are these side notes which you can ignore or look. Some of them have good information. This is like from Codd's 12 rules. Do you guys know Codd's 12 rules? It's fine. He invented the relational database. He was an IBM engineer. And this note just says there's actually 13 rules because he started numbering at 0. And he most of the rules that he did for a relational database are still the rules for relational databases. Things like everything has to be in a table. All the information, even meta information, has to be in tables. Tables are related by means of keys and foreign keys. Tables should only be about one thing. Basically all the rules. And one of his rules was that there should be a language that does everything in the database. There should be one language that you can use to create objects, manipulate data, add data, and SQL became that language. Interestingly, he didn't like it. He didn't like SQL, but it is the language that has evolved to become that language that does everything in a database. You can do literally everything a relational database does with SQL. A lot of really adept database administrators never look at the GUI. It's all just command line in SQL because you can do everything with SQL. We're not going to get to there. We're in the GUI because there's a lot of really specific SQL that is just for manipulating the environment. And that SQL varies depending on the product too. So the stuff that we're going to learn is 90% the same across all products. So the stuff we do in Postgres will look a lot like the stuff you would do in Oracle, will look a lot like the stuff in SQL Server. Most of it will be identical. Some things will have some differences. when we create tables and objects, that's where things get a little bit different because the ANSI standards, you guys know what ANSI is? American National Standard for American National Standard Institute. There's also International Standard Institute. There's another letter in there I'm forgetting. Anyway, SQL belongs to both of those. So every relational database tries to implement that standard, but the standard has some flexibility which allows you to add stuff. And it says you have to have a float data type, but it doesn't say what you have to name it. It says you have to have an integer data type, but it doesn't say what you have to name it. So, I mean, the data type names are quite a bit different in different places. So this is interesting, but not super important. They often divide SQL into different functionalities. DQL, the data query language, that's where we'll start. Spend a lot of time on that. DML, data manipulation language, that's like insert, update, and delete, those kinds of things. Data definition language, that's where you create objects, like creating a table, creating a database, that kind of thing. And data control language, which is more the administration stuff, having to do with administration functions and things like that. We will cover all of those, but not all in equal depth. Questions? Anytime you have a question, stop me. Listening to me ramble on can get pretty boring, so questions can be good. I also have a side note there that there's some debate as to what SQL stands for, if it stands for anything. Have you ever heard that? Some people say it stands for Structured Query Language, and some programmers object there's nothing structured about it and it's not really a query language. Others say that it is just 3 letters like C or C++, it's just SQL. They usually say to say it as SQL because there was an original language called SQL, which was spelled S-E-A-Q-U-L. And technically it's copyrighted, but I don't care how you say it. I say SQL and I say SQL both. So, all right, I talked a little bit about one thing you might not know is SQL is fairly ancient, SQL. I mean, it originated in the 1970s. As computer languages go, that's at least the Paleolithic. It's grown a lot over time, though. And I talked about how it is fairly English-like. You know, select last name, first name, email from person where last name equals Smith. So that's fairly English. You're selecting 3 fields, right? Last name, first name, email from a table called person where the last name is equal to Smith. You know, that's about as English-like as a programming languages get. Couple little warnings. The quotes must be single. It does differentiate between single and double quotes and how they function. Caps don't matter. I broke this lines based on the keywords, but you don't have to break them. It could all be one line. You could break it however you want. Each one of these could be on a separate line. You know, white space doesn't matter as long as it's clear what the keywords are. And line breaks don't matter. Semicolon technically completes any statement. Does that make sense? You've probably done enough SQL to do that. As I said, this is equally valid. There's no difference between that and the other one except how it looks. So whatever's readable, whatever makes it readable to you. This one won't work because it can't tell what select. Can't read that. I'm not going to go over the NoSQL stuff. I have a little bit on the demand. There's a lot of demand. If you look out there, a lot of jobs ask for some SQL. So Postgres, why Postgres? This is a little bit about that, and I'm not going to go into it a lot, but it is open source. It's fairly old. It's older than MySQL. It's free for all users. It has a long, rich history of development. It's a much more robust database than, say, MySQL or MariaDB is. They became more popular because they were simpler, actually, because they were faster and simpler, and mostly what they are used for still is as content managers for web pages. And for that, it's really good. But if you need more complex structures or more complex security, Postgres or some other database would probably be a better choice. For content management, MySQL is pretty good. Postgres has tried over the years to implement as much of the ANSI and ICO standards ISO standards as possible. So it has a rich SQL, right? So I can show you things that some of the others don't implement. It's actually, so Postgres has been around for many decades, but they've been tinkering with it and adding to it and playing with it, and was mostly in the secret. I mean, not a lot of people were using it until fairly recently. And recently it's gotten a huge rise in popularity. People are seeing it as a substitute for Oracle, since Oracle costs tens of thousands of dollars to use and Postgres is free, and yet has a lot of the features that Oracle does. And I had a few notes about that, but it has become really, really popular recently. And it's a good database. It's a strong database. I like it, actually. It's fun to play with. I don't know if you'll like it, but I do. All right. How do you guys feel about the basics of relational database? Feel pretty strong with that? 'Cause I won't review it. If you feel like you need to review it, you can. The tables, I tried to normalize them fairly well. So this is like the person table. This is donations, and the person is just tied by the key number, right? All the keys in here are auto numbered, so they just populate automatically. I think that's the best strategy. The only time that gets you into trouble is when you're merging databases, because if both databases have auto numbered keys, it can get really confusing how to do this.
You can set them up to start at a number, though, can't you? So that if you were...
If you knew that you were going to merge?
Yeah.
I believe you can, yes. I'm trying to remember the identity. I think the identity function is the one that does it. And I believe it takes two arguments, the starting and the increment. But I'm trying to remember. I believe you can anyway. Also, like MySQL, you can overwrite the number if you want, as long as it doesn't conflict with another key. Things like SQL Server won't allow you to overwrite an auto number, but this one will. This is a little bit about normalization. I will just mention it briefly. I'm not going to spend a lot of time on this. Data should be entered only in one place, right? One of the things, you're not going to have to design the database because it's here, right? We're just going to be running things in it. We will add some tables to it later. But part of the idea of normalization is the data should be only in one place. So I have a person table, and that person table in the community assist contains donors, it contains the employees, and it contains the clients. All of the names are in the person table. How do you know if they're a donor or a client or an employee? Well, their key will be, if they're a donor, it'll be in the donation table. If not, it'll be in the client table, or they'll be an employee. Does that make sense? But you only want to enter their information in one place, and you don't want to have multiple tables where you're entering people's information. And it's possible that a donor could be a client at some time, or that an employee could donate, or etc. So you should not enter lists or arrays of values. You shouldn't have something where if they have multiple phone numbers, you shouldn't separate them out with commas or something. You shouldn't do that. So every field should have one value. And that value might consist of multiple words, but it's one logical value. So what that means is you have to break off tables, and like in Community Assist, their addresses are broken off because some of the donors have multiple addresses. Does that make sense? So basically, there are tables in here that are nothing but numbers, right? As I've said in the 220 class, basically, relational databases are not meant to be humanly readable. They are for the computer. They are designed for the computer. The computer can resolve them. Part of what SQL is about, though, on the select side, and that is bringing it all back together in ways that are humanly readable. Does that make sense? When we talk about joins and things, we can bring back what the status is. Well, actually, that's just a key. We can bring back the more information about the grant application. We can bring back what the word for the status. We can bring it all back together in a way that makes it readable. SQL allows that. I'm going to skip some of this. So, I'm not going to go through all this in great detail either, but Community Assist. Have some of you encountered my Community Assist before? No? Okay. It's an imaginary charity, right? And it's a charity that gives cash to people at one time for certain kinds of needs, like rent or childcare, or food, or school. So there's a list of categories where they can give it, and there's a max. There's a one-time max and a lifetime max for these. I'm not sure if the numbers make sense as such. I wrote it a long time ago, but so, and then there are grants for people that request. Each request has to be reviewed, and then if it's granted, they're given that amount. They might be given less than they asked for, or they might be given the full amount. So there's an application for a grant, and then there's a table for assessing the grant. These are the status for the different grants. There's also donations. You can give a donation. And for a donation, you basically, it's just the person key, the amount they donate, the date, and they're given, this is called a universal resource code, is that right? URC, whatever it is. It's just a bunch of numbers. It looks like a key that you use when you type in software keys. So that's auto-generated, and it's just, it would give them a key that they could prove their donation with. And then there are employees. These are the positions for the employees. The employee table doesn't have any, just has the employee key and the person key. I could have more in there. I don't know why I didn't put a higher date. I put the start date under position, what date they started the position. Okay, and then there's this looks like the person table. There's a password table, which I don't know, we may use a little bit. There's a couple ways to handle passwords. One is to let the server itself handle them, which works really well in an environment where you have a set number of people. even hundreds. It could work if they're set. But if something like this where it's wide open, what I do is that in the website there would be a login for the website as an application. And then once they're in, they have to create their own login, and it's stored in the database. And then the login is hashed. And Postgres has a nice utility for hashing. So it's kind of fun to see a hashed login that go on forever. Because I think I used 64-bit hash. It's actually supposed to be better to use 128-bit hash. A hash is different than encryption in that it's not reversible. It's not, with encryption, if you have a key, you can get back to the plain text. But there's no key here. There is a key that tells it it's the number it starts with when it starts the algorithm for hashing, which is very hidden. But there's no, in an ideal hash, there's no way to return it back to plain text. So this is, I don't know if I can make it big enough. Again, this is in the book. It's in the chapter. You have access to it. I'm not going to... The hardest part initially when you're doing this is going to be to figure out where things are. Does that make sense? Because you didn't make the database. It'll be alien ground for a while. I'll try to help with that. But now again, this is the one for... excuse me. That'll be used for samples. And we've got probably the key one table here is person, that has all the people in it. There's a table for donations. There's addresses for those people. Some of those people are employees, and the employees are attached to their positions and the job positions. It's the employees that review the grants. Some of the people make grant applications, they will all have a certain type. Down here they have a status, is whether they're pending or granted or denied or whatever. And this is a lookup table of the different possible statuses. I think that's most of them, other than there's a login table, which gives their password and their username, ties it to the person key. This, every time they log in, it's supposed to keep track of it, right? So it's a history of all the times they've logged in. This, actually, I think it's empty right now, and it shouldn't be. This was just business rules for the database, just a reference table, which I may have to, I think last time I looked, it was empty, and I don't know why. But it's not hooked to anything because it's not really part of the database. Does that make sense? As I said, getting your way around in here is going to be the hard part. So the tech certificate, I think I'm just going to go to the design. And then we'll be about done. So this is going to be hard to see. No, that's not what I want. I want it bigger. I just don't want that thing to stay up there. If it's any consolation, one of the things that one of the reviewers of the book, because they have to do peer reviews, said is that he thought the databases were too complicated. I wanted complicated enough that you were working with something semi-real. I mean, real databases are more complicated even than these. But we have a person table just like the other one, except that the address is in there, because everybody only has one address in this one. There's again a login table and a login history. So there are different certificates that people can earn. So there's a certificate course. This tells which courses belong to the certificate. Okay, so these are the actual courses. This combines the courses with the certificate. It is possible to substitute a course sometimes, right? You guys do that here sometimes. So a thing, if you can't take a particular course because of timing or something, maybe another one will work. This is just what persons are the certificate administrators as opposed to the instructors and things. There's also an instructor one, they all link to person. There's a status that's linked to everybody. I don't really use it anywhere. Probably should get rid of it if I were simplifying. But the statuses, are they active? Are they, particularly with students, have they finished? Are they active or have they dropped out, basically, disappeared? The instructional area refers to what the instructor, so instructional areas are they database, are they web, etc. And this combines the instructor with the area because some people can teach in multiple areas. There's a price history. This is a little confusing, but prices go up, and you don't necessarily want to delete former prices when you add a new price, right? So you keep track of what price for what years or what times, and then that gets tied to this section. And this is hard to see because it's under this, but the section is where what course is being offered in what time, right? So a section is a course offered in a particular quarter at a particular time. Does that make sense? With a particular instructor. And then, where is that one? I want oh, it's off the screen. There are a couple more. There's student, right? Now student, it has a person key, so they're in the person table too, but they're listed as students. They do have a status. And then there's a roster, and what the roster does is it ties the student to the section, the course section. And the roster also has their final grade in it for that course, and you can use it for things like GPAs and things like that. That's complicated, I know, and you're going to have trouble finding your way around initially. Questions on that? Now, some of these, I will say, when you get into the data, some of it's pretty bizarre because have you ever gone on the web and used one of those data generators? There are things on the web that you just say, I want 100 records of this type. And it'll do that for you. And so I think actually I typed in all the roster, but there's like 3,000 records in roster. There's a fair amount. It still doesn't quite add up to totally consistent, but and the names, people's names are really bizarre because of that generated thing. Okay, I'm almost done. And this just talks about Postgres, using the fact that the tables are under the schema. We will later in the quarter we'll create our own schema. You can break out different schema. It can be a good way to organize things. And I don't think I actually assigned these exercises, but it is once you set up. It would be mostly creating a query tool, and I suggested going through each of the tables with select star from the table, just to look at them. If you get familiar with them, it'll be easier when you have to go searching. And again, if you show up on Tuesdays, I will help you. I don't need the project ID. I think I've deleted that since. Questions? That's a lot. I would like to have done more of it hands-on today, but the virtual machine isn't there. Again, if you have your laptop, you're welcome to do it at your laptop. You can do it at home. And you can have it in all three places if you want. Just know that they won't be synced unless you put it on a cloud somewhere. It'll be fun. SQL's a fun language, and we'll do some fairly sophisticated things before we're done, not just selects. No questions? Oh, yeah. Yeah, I mean, you could save it anywhere because you can just upload it It's just a text file, right?
Oh.
So, so the server doesn't move around very well, right? But the SQL. So let's go back. PG admin. So let's do a quick query tool. I like to have a little bit more room up here. This is interesting. You can put scratch pad. It literally is just a scratch pad. So if you have some ideas for queries but you don't have it, you can put it over there. If you need some notes, that's what it's for. But I'm going to do. Let's just do. Put it over there. I don't want it over there. I'm just going to do select star from, let's do course. And I will run that so it'll show me all my courses. I can widen that out. So if I want to save this, there's a little thing here, a little disk. I think I can also do file. Actually, it doesn't have save, so let's just do the save here. It'll ask you where to save it. I mean, so I'm not sure where it's going right now. It's at, oh, here it's at C. How did I get to wireless data? I don't want to go there. Theoretically. Let's do it again. There are things about this that are a little bit annoying. It actually still has some of its, so when I do that, I could go to users. It goes to C root for right away. And then in users, I could go here. And then I could go to, say, documents. And then I need to give it a name. And it'll add an SQL automatically. That's that. And I do create. And it'll just be in, so I go to documents. There's test SQL. It asks what to open it with. I could open it with that. But it is, it's just a text file. So I could open it with Notepad. Doesn't have to be Notepad Plus even, but there it is. So it's just a text file. It's really easy to move around. So you'd have to have the database in both places, probably. Yeah.
Is that pretty much what you want for your assignment turn in, unless it specifies others?
Yeah, basically I just want the SQL. I can tell most of the time from the SQL whether it worked or not. And some of these will have hundreds of answers, right? Hundreds of results. I really don't want to see hundreds of results. So the SQL is fine.
You don't want screenshots or anything, you just want that
Just the
file.
SQL file.
Okay.
But yeah, if you're going to run the database here and at home, you'll have to have an installation of the database here and at home. Again, unless you want to try putting it on AWS or somewhere. But but these files are really, really easy to move around. They're literally just text files. I closed all that. Did I want to do that? I guess I did. I'm going to stop the recording.